Welcome, guys, to TUM Technical University Innovation Day. My name is Vincent Mbugwa, and we are from the Faculty of Applied and Health Sciences. With me is
Martin Muturi Washira.
Our innovation title is Solar-Powered Greenhouse Plant. And in solar-powered greenhouse plant, we entail at addressing the problem of food shortage and also in reliability of food supply in our community. As we know, weather tends to be unpredictable. Some year we end up having enough food. Some year we end up having no food at all due to drought or due to pest in our infestation in our farms. So with our project, it entails at least having, with our innovation, it entails at least having production at 90% maximum, more than what we could have get from if we depended on the weather patterns. So it's also in line with our Kenya Vision 2030 in the sector of food and also the SDGs goals, in which we entail at solving the problem of hunger and also trying to create employment opportunities. Okay,
The plant comprises of a solar panel which provides chill energy, which is then stored in the battery. And then we have a control box and a tank which stores water. On the tank there is a water level sensor and a pump which pumps the water to the field. In the field we have got the greenhouse. In the greenhouse we have got two sensors, the humidity sensor and the temperature sensor.
So essentially, the operation of this greenhouse, we did set the condition to tomato plants. So it can be developed to be set in condition for other crops, but we chose to do it for demonstration on tomato plants. So essentially we know that tomato require a temperature in between 17, but it should not bypass 35 degrees. So when it bypasses 35 degrees, it means the yield of the tomato plant will go down. So in our greenhouse, the condition set for tomato is that the temperature should be maintained between 17 and 33 degrees. When it goes beyond 33 degrees Celsius, we have the mechanism here, of which it is being controlled by the setup in the control box here. And we have a field. In the field, we have a fan, in which the fan automatically kicks in to regulate the temperature within the greenhouse plant. Essentially, in the operation of the greenhouse, it is done manually, in which when the temperature increases, you have just to go in and check it. You feel it for yourself and open if the door are there or the windows. But with this, you don't need all those activities, as it is incorporated with a fan, which regulates the temperature within inside. And also for tomato plants, we know that tomato require a soil moisture content in between 1 to 3 inches. So with me here is a moisture sensor, soil moisture sensor, of which it is used to sense the level of water or the water content in the soil. And when the water content in the soil bypasses the required amount, of which I said is 1 to 3 inches, when it goes below 3 inches, it means we need to rewater our tomato plants. So the pump here is set to automatically kick in and supply the water in the farm when it goes below 3 inches. So also, the temperature here is regulated by the fan. We have the humidity sensor, which should be placed centrally to take we can say the relative or the average temperature of the greenhouse, so that when the problem arises, it kicks the fan and the temperature is regulated. In the tank section, of which we assumed it should be placed somewhere outside, so you'll not be going there to automatically monitor it, in that you'll go check the water level at what percentage or at what level it is. No, you'll just be sitting at the control set point, it will be just like a room, of which we have a display here, an LCD display. It acts like your monitor or your screen on which you check the parameters within the field. The parameters within the field, of which the physical parameters, the water, the temperature, are just converted by the sensor to digital signals, of which can be displayed on the screen. So your work will be just to be checking on how they're varying. When the water levels goes below, in our case, this level, we did take it to an estimation of 3 centimeters. So when it goes below 1 centimeters, we have a pump of which it is connected outside and it will automatically refill the tank. So your work will just be to checking if the electronic gadgets are operating well. So these 2 pails here represent our farm. This wet farm is when the soil moisture content is at its best, or it is at its set conditions. And this one represents when the soil is dry. So essentially what happens here is when the farm is well watered, it means that there will be no water running into the farm. But when the soil is dry, it means that we'll need to rewater our tomato plants for our case. So it means that when you remove it, the water automatically kicks into the farm, and the water starts running to the farm until it is well watered. And it means when it is well watered, when it reaches that level, the pump automatically stops. You can see it as automatically stopped. So for the temperature part, here on the LCD display, it shows the temperature is at that. It means that the condition in the greenhouse is set. What about if it bypasses 30? We'll see what will happen. So the fan is running to regulate the temperature within the greenhouse and also the humidity. So when it goes below 35, 34, it should automatically stop. And also for our case, we realized that during the night, plants require light to photosynthesize. So we did set a light sensor here. It's an LED. So the light sensor, we did put it in the range of percentage, in that when the light goes below 50%, it means that the bulb inside the greenhouse will automatically light to also increase the temperature during the night when the temperature is below the set point, so as to rise the temperature to the required set. So as we are using the renewable part of energy, it means the continuous process that is running in the greenhouse should be equivalently cheap, because you'll not need to incur at the end of the month be paying for electric bill, but instead you'll be having your own source of energy. Thank you.
Our message to the new students is that as a community we are facing very many challenges, and we should try and use their great minds and time to try and solve these problems.
Yeah.